Hi, I'm Ethan Campbell,
I'm Katy Christensen.
and we're PhD students in the School of Oceanography at University of Washington in Seattle.
Our co-author in this work is Mikelle Nuwer, a teaching professor in oceanography.
Our presentation is titled Cracking the Code, a flipped virtual approach to teaching Python. Python is a programming language that's become ubiquitous in scientific research, as well as applications outside of academia, like data science. But undergrad programs in the earth sciences haven't kept up with the need to train students in current Python programming and data analysis practices.
With this in mind, last year we redesigned an introductory 200-level Python course that's been offered in oceanography since 2015. Our goal was to adapt it to a virtual format, given the pandemic, but also to convert it to a flipped model and infuse our teaching with structure and active learning techniques. Research has shown that these can increase students' understanding and retention of material. We then co-taught the course to 25 students in autumn quarter of last year.
So the leftmost panel of this poster shows our instructional approach. We created 41 Panopto videos released within 14 flipped lessons. During Zoom classes, highly structured group work allowed students to practice Python skills from the videos. Then they applied those skills to real data in 4 assignments. A Piazza Q&A forum and virtual office hours were really critical in answering students' questions and fostering a strong classroom community.
We implemented a final project that allowed students to research a topic of their choice, either individually or in pairs, using their programming skills. Check-ins throughout the quarter simulated a scientific method, ending in a final presentation with peer review. Underlying the course elements that we've described were intentional steps we took to ensure that our classroom was as welcoming and inclusive as possible.
In this middle panel, we analyzed data from Piazza and Panopto to show how students use those platforms. For example, this pie chart shows that students frequently took advantage of anonymous and private posting options. This time series shows that students watched 80 to 90% of flipped lesson videos in most weeks, and that assignment deadlines kept students engaged with Piazza.
In the right panel, we correlated anonymized student metrics to explore what strategies predicted success. For example, we find that students who collaborated with peers, monitored Piazza more frequently, and watched flipped videos before rather than after class tended to earn higher grades.
We conclude that our redesign of this course was successful in keeping students engaged and learning under adverse circumstances. We believe our findings speak to the effectiveness of flipped instruction and the power of versatile platforms like Piazza. More specifically for programming courses, we find that focusing on active learning, adding structure, and offering ways for students to get help can level the playing field for those who come in without much previous coding experience.
Thank you for watching. We hope you enjoyed our presentation.